6a, we have a small dam is in the shape of the area bounded by y equals x squared and y equals 25. So this is y equals x squared, a parabola. Just make a sketch of that. Always make a sketch to begin with. Here's the line y equals 25. And find the force on the area below y equals 9. So below this point, so all of this is water from the surface at y equals 25 down to here. This is the bottom. So we're starting to integrate. We want the depth from y equals 9 down here to y equals 0. Okay, so first of all, here's our integral that we use. F equals w, integrate from a to b, L as a function of y. This is our L value, right? It's the length of this element. H of y, which is our height of the element here. And in order to do that, we're going to integrate with respect to y here, not h. So that means we need to get L and y, sorry, L and h in terms of y. So this is h in terms of y. H is a function of y equals 25 minus y. Now why is that? Well, because we're starting at 25, and then our height is going after this element is going to be y, but then our depth h is going to be measured from this line down to our element. So that's actually 25 minus this height y, this little y bit right here. So that gives our depth h in terms of y. The next thing we need to know is, according to symmetry, there's the same amount of the element on either side of the y-axis here. So we have this part of L and this part of L right here. It doesn't quite look like it in the diagram, but it should be the same distance. So it's double x. So L is actually equal to 2x. So then if we take our function y equals x squared and rewrite that as x as a function of y, we get x is y to the half, or y to the square, square root of y, which is y to the half. And our W is 9,800 newtons per meters cubed, which is 9.8 kilonewtons per meters cubed. And our limits of integration, now because we've done this in terms of y, we actually have to start at the bottom here and integrate up in y. So we start at y equals 0 and we integrate up to y equals 9. Therefore our limits of integration is 0 and up to 9. Okay, so then we plug in the L as a function of y, which is 2y to the half. There's a little mistake there actually. This should be just, y just should be raised to the half. So just notice that the 2 is not raised to the half. That mistake is not carried throughout the problem, but just be aware that it's not the 2 raised to the half, it's y raised to the half. And then h of y is 25 minus y. So we do that integration, take out the 2, right? We'll factor out our 2 here. So it's 2 times 9.8. Then it's 25y to the half minus y to the half times y is y to the 3 over 2. And then we integrate. So integrating y to the half is y to the 3 over 2 over 3 over 2, which remember we can flip that and write as 2 over 3. And y to the 3 over 2 integrated is y to the 5 over 2 divided by 5 over 2, which again we can flip to call the fraction 2 over 5. And then we're integrating from 0 to 9, so we substitute in our 9. We don't need to substitute in 0 because 0 gives us all zeros anyway, so we'll just substitute in the 9. And if you go through the math here, you'll get the square root of 9, right? 9 to the 3 over 2 is the square root, then cubed. So that's half, 9, square root of 9 is 3, raised to the 3 is 27, divided by 3 here is 9. So if we multiply all that out, 2 times 25 times our 9 that we get from reducing the 9, 3 over 2, and the 3, we get 450. And then the same here, 9 to the 5 over 2 is 243, you could check that out, and times 2 over 5. And then you go through this problem here, you reduce the calculations, and you actually get 6,914.88 kilonewtons. But I've changed that to meganewtons. Now remember, 1 meganewton is 1,000 kilonewtons. So you actually have to divide by 1,000 here to get the meganewtons. And that is the answer.